So before I talk about angles or degrees or anything like that, I want to start by talking about the radius. Let's go back to the basics. So you already know the radius is like the distance from the center to the outside of the circle. The reason I want to talk about the radius is because it helps you measure more than just that distance. If you think about it, the radius can tell us the diameter, which is just twice the radius. Just looking at the circle, you can probably wonder, how many of these radii does it take to fill up the whole distance around the circle or the circumference? So what we can do is we can, take our radius and see how many of them fit on the circumference of the circle, and let's just see what happens. All right, so it takes this many radii to fill up half of the circle, right? So let's talk about what each one of those radii gave us. So each time we ran one radius along the circle, it created an angle. And that angle is special because that angle is created by an arc that's the same length as the radius, and that's what makes it special. And so because it's so special, they gave it the name a radian. And that's what a radian is. It's the angle that's created from an arc that's the same length as the radius. So that's why they sound alike, radian and radius. And so just like how it took us 3.14 radii to get around the half of the circumference, you can probably guess how many radians it'll take to get halfway around the circle in terms of its angle. All right, so that, like I said, that angle is called a radian, and it takes 3, and you already know how many more of those radians to get through half of the circle. So looking at the radian as a way to measure angles, just like how we measure degrees in Fahrenheit and Celsius, we can measure angles in degrees and radians as well. All right, so now we can say that pi, that many radians, is equal to halfway around the circle, so 180 degrees. All right, so if that's the case, then it takes double that amount to get through the full 360 degrees. So that'd be 1 pi plus another pi, so that's 2 pi. Now we can keep using this process to figure out all the angles that fill out our unit circle, like we talked about in the last video. We can use the fact that we know pi radians is equal to 180 degrees to help us fill out all the important angles in our unit circle. All right, so if I start right here, that's 0 degrees, and if I go all the way around, that's 360 degrees. So I know 180 degrees, that's gonna be equivalent to pi radians. And then that means that 360 degrees is going to be double that, or 2 pi radians. All right, so I know if 90 degrees is half of 180, then that's also going to be the same thing as half of pi, which is just pi over 2. And then half of that is just 45 degrees, and that's going to be equal to half of pi over 2. And you can think of that as 1/2 times pi over 2 or pi over 4. And so what you know is that that's another conversion we can use. 45 degrees is equal to pi over 4 radians. And so just to check, just to make sure we're doing it right, if I do 45 degrees, that's pi over 4. And if I add another 45 degrees to get to 90, that's 2 pi over 4, which simplifies to pi over 2, so we're good. And then if I want to add another 45 degree angle, that's adding another pi over 4. So we got 1 pi over 4, 2 pi's over 4, now 3 pi over 4. That's going to be equal to 90 plus 45 more degrees. All right, and if you think about it, we can just keep adding increments of pi over 4, and that's going to be the same thing as adding 45 degrees. So if I go from 135 plus another 45, that's 3 pi over 4 plus one more pi over 4. So that's going to be 4 pi over 4, which simplifies to pi, so we're good. And then if I add another pi over 4, that's 5 pi over 4. And that's going to be the same thing as 180 plus 45 more. All right, now if I add another 45 degrees, that should get me to 270. So that's 6 pi over 4, but we can simplify that to 3 pi over 2. All right, so from here, from 270, I can add another 45 degrees to get me to 315. And that's just like going from 6 pi over 4 to adding another pi over 4. So that's going to be 7 pi over 4. And then if I add another 45, that's 8 pi over 4, which we know is already 2 pi. All right, so that basically takes care of all the 45 degree angles. So now the other important one was those 30s and those 60s. And there's a couple different ways you can go about understanding how to do it. I personally like to just add a whole bunch of 30-degree increments, and I can use that to fill out the rest of the circle. All right, so the way I like to split it up is looking at from 0 degrees to 90 degrees. That's 3 pieces of 30 degrees. So you got like the 30, the 60, and then the 90. So if I can take pi over 2 and divide it by 3, then that'll give me how much each 30-degree angle is. And so if I want to just do that real quick off to the side, you got pi over 2, and you're timesing it by a third to see what is a third of that 90 degrees. You can see that that's just pi over 6. And then if that's the case, you know, if you're trying to do 60 degrees, that's just pi over 6 plus another pi over 6, which is 2 pi over 6. And you can see that that'll simplify to pi over 3. All right, so by now you basically got all of your basic conversions. And so I'm gonna just use these to basically fill out the rest of the circle. So you know how it was 2 pi over 6 to get 60 degrees, 3 pi over 6 to get to 90 degrees, and that 3 pi over 6 simplifies to pi over 2. So if I go another 30 degrees, so that's another pi over 6. So that brings me at 1 pi over 6, 2 pi over 6, 3 pi over 6, 4 pi over 6. And that's going to simplify to 2 pi over 3. And then from 120 degrees, if I add another 30, that'll get me at 150 degrees. So that's what 1 pi over 6, 2 pi over 6, 3 pi over 6, 4 pi over 6, 5 pi over 6. And just to check, you know, if I add another pi over 6, that's 6 pi over 6, which is just pi. And I can add another pi over 6 to get me 7 pi over 6. All right, so from 210, if I add another 30, that'll put me at 240 degrees, which is what, 8 pi over 6. And that can simplify to what, 4 pi over 3? 4 pi over 3. All right, so if I got 8 pi over 6, I can add another one, 9 pi over 6, which does simplify to 3 pi over 2. All right, so from 9 pi over 6, you add another one that's 10 pi over 6, which simplifies to what, 5 pi over 3. From 300 degrees, I add another 30. That'll bring me at 330 degrees. 10 pi over 6 plus one more, that's going to be 11 pi over 6. And then just to check, you know, one more would be 12 pi over 6, which simplifies to 2 pi. So that's pretty much it. That's how you fill out all of these angle measurements in radians. And it does look like a lot, but you know, as you work with it more, you'll just start to be more comfortable with it. And I know it might not seem preferable now just because it's new and we're just so used to stuff being in degrees. But in the next video, in part 4, you'll see how the radian measure, it makes a lot more sense and it's a lot more convenient. So another thing to think about when you're trying to convert from angles in radians to degrees and degrees to radians, just know that if it ends in a pi over 4, then it's going to be some increment of 45 degrees. And if it ends in some variation of pi over 6, and it could be simplified or written as pi over 3, but it still can be broken down as pi over 6 in some way, And so you know that's some increment of 30 degrees. So that's just one thing I like to do. So in part 4, we're going to talk about how these radian measures tie into the sine and cosine. And then we're just going to look at some trig functions and then be able to graph them. So stick around for the next video.